If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You're listening to AFM radio on Astronomy.FM, around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is Astronomy.FM.
The pirates are coming. The pirates are coming. The pirates.
Arr! It's Space Pirate Radio time. Buckos here on Astronomy.FM radio. That means it is another Wednesday evening. This one happens to be November the 1st, 2017, 9 o'clock in the evening for me here in the eastern portion of North America. And, of course, that also means universal time. It is still 1 o'clock in the morning on Thursday morning, November the 2nd. So that means, yes, this is the live presentation of our program right now. And we will be repeating this program every 4 hours for the next 24 hours. But during the live presentation, come on over to the chat room. Easy to get here. Just go to the homepage, astronomy.fm. You'll see where it says radio chat. Click on that. It'll get you to the login page. Type in a name, hit login, and you will be here. I'm reading chat as we go along, so I will, if you have any questions for me, I'll try to answer them right on air for you right now as best as I can, as long as I can see them. And, well, I'm kind of hard to read and talk at the same time, I found out. Unless you're talking about the same thing I'm reading, then that's easy. I want to say hi to everybody that's in our chat room so far. So far, there's me, Black Projects, Evil Spock, Twist Edge, Plaid Mac, Plaid Joan, Richie, and Aqua for you. So come on board, everybody. I always consider you part of the crew when you come on into the chat room, and we'll set sail shortly. Captain Dianne is a little AWOL right now. Don't know where she's at or if she's coming in, but if she gets here, we'll certainly get her into the show. So maybe some computer problems. Haven't heard yet, so we'll find out. So we'll continue on, everybody, and we'll kind of just go along as usual. All right, let's start out with the sun, as I like to do, as being the center of the solar system. And kind of all important to us, of course. So far, the sun is not much of anything. No sunspots. One minor active region. Doesn't look like it has any spots at all. So it's kind of one of those suns where you have to, if you look at it on your computer, you have to clean your monitor because you might think a little speck of dust on the monitor is sunspot, but no, it's not. So pretty quiet. Not much happening, though. There's been reported a coronal hole on the sun right now, which is shooting out some particles. And that means we could get some auroral activity, but it's going to be high latitude stuff like around the Arctic Circle. So if you live up in the northern zones there, you have a chance of getting some auroras. I know the solar winds are pretty slow, and the particle density is kind of low. Watch for it the next couple days. Go to the NASA website for SOHO, and there's a needle there that gauges the speed. And they publish the particle density too, and you get an idea. Watch it for the next couple of days and watch it start climbing as we get some particles coming from the sun because of magnetic fields. Basically opened up the outer atmosphere of the sun, allowing particles from the surface shoot out into space and travel through the solar system, get picked up by our own Earth's magnetic field, bring it down towards the magnetic poles, which are kind of close to the actual rotational poles. And when the energized particles are brought in, they interact with the atmosphere of the Earth, energize them, and then they cause them to glow. And that's what we see as northern or southern lights. So a chance for that tomorrow, next day, something like that. So if you're living up like, Alaska, top of Canada, northern countries of Europe, Asia, stuff like that, you got a chance to see some aurora, which almost get to be continuous. In the sun is slowing down. Definitely less sunspots, less activity. Visible light, pretty much nothing at all right now, and it's going to get like that. We'll have several days, weeks, maybe even months where there won't be any sunspots at all. Right now we should be in kind of a transition phase. Definitely coming out of maximum, heading towards minimum. And, right now it's like every few weeks, nothing. And then we should get a few, and then nothing, and then a few. And then we might get another long stretch of no sunspots, like we did the last time around. Was that our 10 years ago or so, when we had almost no sunspots at all for about 2 years in a row. Well, we'll see what happens. If you have a hydrogen alpha telescope or a filter for your telescope, you still have a pretty good chance of seeing things on the edge of the sun called prominences, where the gas is condensed in the upper atmosphere of the sun, and just above the photosphere, I should say, around the chromosphere. And you get to still see some prominences even during solar minimum. Just not much happening in white light that most telescopes look at, filtered down, of course. Sun getting a little bit quiet. I'll give you a rundown on what's happening in the skies as far as the moon and planets go. Let's see. Tonight we've got Venus 4 degrees north of the star Spica. We've got on Friday planet Uranus 4 degrees north of the moon. Saturday, full moon. Okay, not a good weekend for doing some deep space observing. The full moon, like galaxies and star clusters and nebula and stuff like that. Definitely not good to do during the full moon. You can see some bright stuff, though. You can still see variable stars. If you're a variable star monitor, you can obviously still see plenty of variable stars. You can look for double stars if you like to do that. And, of course, planet watching is always good, even during a full moon. You can actually watch the moon cover stars if you know when to look for them. That happens. That's kind of fun, too. Not so much during a full moon, because, again, you can only see the brighter stars. But when it's a crescent moon or quarter moon, then you get a chance to see the moon cover some of the fainter stars, or some of the stars will pop out from behind the moon. So it gives a little bit more activity to do. And also, during a full moon, the sunlight actually shines straight down into the craters, and you lose contrast on the craters. That's what makes them a lot more difficult to observe. When the sunlight's coming in more at an angle, the crater rims will have, and the bottoms also will have more shadows. Mountains on the moon will have more shadows, and that gives you a better contrast between the shadow and the bright parts of features on the moon, and it makes features stand out a lot better. Full moon, nope, basically shining straight down, and the light's coming right back at us. But you also might notice that the full moon, parts of the full moon itself are actually brighter than other parts of the moon. Yeah, because the material on the moon is actually reflective in a way that it tends to kind of make the sunlight bounce straight back at us. When it's bouncing at an angle, we don't get quite such reflection. So the full moon, yes, is the brightest moon, having light straight down and then straight back at us. Now, the moon really is not all that bright. As far as the particles of the moon go, try looking on an asphalt road. Asphalt's basically pretty black. Well, kind of like the moon. Moon material is also pretty dark, but the sunlight hitting it is pretty bright. It's a bit reflective, so combined all together, the moon looks like it's actually bright white, but it's not bright white material. It's actually fairly dark. So kind of like looking at a normal asphalt road during the daytime. It doesn't look like it's jet black, but fairly bright. And depending on the sun angle too, will change how sunlight comes off of asphalt. So it kind of gives you an idea of how dark the moon actually is. It's really not all that bright. Coming up Monday, the moon will be at perigee, which means it will be at its closest in its orbit to the moon. So now if the perigee and the full moon happen to occur on the same day, then we call it supermoon. Well, some people call it supermoon. It just means that when the moon is closer to the Earth, it actually is technically a little bit closer and a little bit bigger at the same time. Mostly, that happens every month, actually. The moon's always at the closest point to the Earth. The moon's always at the farthest point to the Earth. And if they happen to line up with a full moon or new moon, some people think it's something to note. But, no big deal. All right, coming up Monday, Aldebaran will be 0.8 degrees south of the moon. There will be an occultation somewhere in the world. Let's see, that's at 3 hours Universal Time, which is 7, 8, 9, 10, 11 o'clock for me here in the eastern part of North America. So I don't think will the moon be up then on Monday, 3 days after full moon? Maybe. Aldebaran's kind of in the morning. No, not quite in the morning now. It's rising a little bit earlier. So I'm not too sure if this occultation will be visible from me or not. Let's see. I have to double check that one and see where it's actually visible at. So check your star chart for your area and find out if you can actually watch the moon go in front of Aldebaran. And that's pretty much it for what's happening with the moon and the planets. If you're watching your star chart, especially if you got a computerized star chart like I do, I use a program called Stellarium. You can watch those morning planets. They're doing kind of a bit of a dance early in the morning, just before the sun rises. And believe me, this is a little bit easier to watch on a computer than it is in the real sky. So some of the planets are actually getting closer to each other early in the morning. And you can see, what have we got early in the morning skies? We've got Mars, Venus, and Jupiter starting to come around also. And there will be some close encounters with a couple of the planets throughout the next month or so. First one will be Venus and Jupiter will be really close to each other right around November the 9th or so, early in the morning, just before the sun rises. But unfortunately, they're also pretty close to the sun, way in the sun glare. So technically, you can, they'll be really close to each other, but might be very difficult to see with a lot of early morning twilight. If you've practiced this before, you might actually be able to try observing this conjunction during the daytime. Again, being close to the sun, you got to be very careful not to actually accidentally get your scope pointed into the sunlight. But if you got a computer-controlled telescope, would be a little bit better to tune in Venus and Jupiter during the daytime in about a week or so, and see if you can catch them really close together in the daytime. Again, be very, very careful. This is a bit of a tricky one, so more for experienced daytime planet viewers. And then as more and more time comes up, Jupiter and the moon will actually be getting really close to each other in about another month or so, somewhere around the end of December, beginning of January. We've got another conjunction of Mars and Jupiter. And not quite so early in the morning, a little bit more tolerable. So it'll be about 7 o'clock in the morning, but the sun will be quite a bit lower, being right after the December solstice. So a little bit better chance of seeing Mars and Jupiter together. But Jupiter is going to way outshine the planet Mars and make it difficult. So again, more of a binocular type of telescope object, because Mars is going to be way too dim to easily see it naked eye next to bright glaring Jupiter. Oh, a few things to go look forward to as far as the planets go. Again, I kind of like using it. If you really want to see it interesting, get a computer star chart and a computer program showing what's up in the nighttime sky. And sometimes it's a little bit more fun to check it out that way. Oh, we got a few more people in our chat room right now. So we've got Nord, Sister Plaid, Optronics, Aquafu, Richie. Welcome, everybody. It's just come into our chat room recently. Glad to have you here. Just me so far tonight. We'll see if Dianne is able to show up. If not, it's just me and you, of course, part of our Space Pirate crew when you're in the chat room. So again, come on over, everybody, and join us. Let's see, a couple of anniversaries. Let's see, 17th year anniversary of the first crew on the International Space Station 17 years ago. And also anniversary of the end of the Russian space mission, which had the dog Laika traveling on board. Yeah, the end of Laika and that mission too together. Not the dog. I see Aquafew has been working on telescopes, stuff like that. So some people get into our chat room at off times, and glad to have you do that. It's only generally during the live portions, live presentations, will most of the people be around to answer questions in the chat room when we're the busiest. But if you want to ask questions in the off times in the chat room, please feel free to do so. And I also encourage people to just pop into the chat room, especially our regular listeners. And if somebody out there is asking a question on astronomy, maybe you can answer their question for them. Happen to catch it live, because our chat room is open 24/7. But not everybody can get there all the time. All right, so that's what's happening with the moon and planets lately. Let's see what's going on in general sky. So what I wanted to go for is some stuff in the sky. Like, let's pick up an object in the sky and talk about it a little bit. And I think the object I wanted to go for, I'm going to try to pick one of these each week, a new object to talk about, something a little bit interesting, one specific object. And tonight it's going to be the star Deneb. Generally, a northern hemisphere star in the constellation of Cygnus, but it can be seen reasonably far south. It's not that far towards the north. If you're above 45 degrees north latitude, it will be circumpolar, and I'm just a little bit below that, so it'll be right on the edge for me whether it's circumpolar. Deneb in the constellation of Cygnus the Swan, also part of it known as the asterism of the Northern Cross. It is right along the belt of the Milky Way, and Deneb's an interesting star. With two other stars, Vega and Altair, forms a triangle near in the northern hemisphere. It's kind of known as the Summer Triangle. Three different constellations: Vega, part of the constellation of Lyra the Harp; Altair, part of Aquila the Eagle; and Deneb, again, part of Cygnus the Swan, forming a really nice, fairly large triangle. Deneb is a rather unusual star in that it is a really big, really bright star. But you notice it doesn't look any brighter than Vega or Altair. In fact, it's actually a little bit dimmer. Well, Vega and Altair may be about 25 light years from us. Deneb, not exactly sure, but anywhere between 1,500 light years and 6,000 light years away from us. So that could tell you, this has to be an extremely bright star. If it is 100 times or more farther away than two other stars that are about the same brightness. And yes, Deneb is a massive star, maybe about 25 solar masses. The diameter of Deneb is about 200 million miles. Now, the sun is less than 1 million miles, and the Earth orbits at a distance from the sun of about 100 million miles. So try to imagine if Deneb was inside our solar system in place of the sun. We, the Earth, would be pretty much right traveling on the outer edges, or maybe even slightly inside of the star Deneb. Deneb is a very massive, big, blue-white star. And it's one of the farthest stars that you can actually see in the sky with just your unaided eyes. Spectral class A2, which means that, again, puts it kind of in the white-blue range. Temperature, much hotter than their sun, at about 15,000 degrees Fahrenheit. It has been considered in the past, maybe a little bit prehistory, of it's one of the northern polar stars. Because of what's called precession, our own polar star right now, Polaris, is not always the pole star, but the pole itself of the Earth wobbles around and points to different stars. So about 18,000 years ago, Deneb would have been considered the polar star. Not as close as Polaris, because it would still be about 7 degrees away from the pole, but fairly bright polar star compared to Polaris. And it will be a polar star again in about 9,800 years. So something to look forward to. Stick around for that. Very massive, very bright star, and it also means it's not going to last very long. Bigger stars get rid of their hydrogen much quicker than smaller stars. The solar engine in there is just fusing hydrogen into helium. In fact, it's considered that Deneb has probably already stopped fusing hydrogen into helium. And that means a couple things could happen to Deneb. It could have its core start to collapse, and looks like it's already starting to swell up. It's off the main sequence, which is basically it's not in middle age anymore. It's starting to get a little bit more advanced in age, and it could start changing. It could turn into a red giant. Can you imagine a star that's already the size of the orbit of the Earth getting even bigger? Yeah, that's probably what's going to happen to the star Deneb. And being as massive as it is, depending on how much material is left over after it starts converting helium into heavier elements, and then it'll reach a breaking point where it won't be able to fuse any more elements. The core will collapse and it'll go up in a supernova explosion or a hypernova explosion, depending on how much material is left yet. Deneb is a star that's going to explode big time. Don't have to worry about that. It's going to be quite a long time, though, maybe a few million years before that one happens. So next time you look up at that star in the triangle with Vega and Altair, just try to imagine, it's hundreds of times farther away than the other stars. Hundreds of times more massive, bigger in diameter, and it's going to explode someday. Isn't that fun to just think about specific stars that are actually going to explode? Welcome, Black Projects, into our chat room too. Glad to have you here. Betelgeuse too. Yep. There's lots of stars that are actually bigger than Deneb. Like Betelgeuse is one of them, but Betelgeuse is more of an advanced star. It's already in the red giant phase, so it's big, it's red, but it's also much cooler. So it's been a while since it was in the main sequence, which is its middle age. So Betelgeuse is big and red and cooling down, and then. Yeah, Betelgeuse, I could say maybe 600 light years away, something like that. Don't really, at that distance, we don't really have to worry about if they go supernova. That's far enough away from us not to have to worry about it too much. Well, let's see what's going on with NASA and launches coming up. Yeah, there's a launch coming up on a couple things are going to be launched from NASA. Let's see, on Friday, November 10th, the launch of NOAA, NOAA, it's National Oceanic Atmospheric, something like that. Weather satellite is going to go up, by the way, on Friday, November the 10th at about 4 o'clock in the morning Eastern time. So you can tune into the NASA channel if you want to watch that launch. And then the next day, Saturday, November 11th, will be the launch of the orbital ATK cargo resupply mission to the space station. That'll happening at about 7 o'clock in the morning, local time, to the eastern portion of North America. Again, you can tune into the NASA television and watch those launches. I recommend going to NASA television and just seeing what's going on. They have programs going on all the time about future missions, past missions, anniversaries, launches, things like that. So just tune into them, and it's fun to watch something that is always changing and more interesting current news going on at NASA. Well, let's travel around the solar system with NASA, and let's see, Martian Ridge brings out rover's color talents. Let me pop this article into our chat room here. I was try to put articles in our chat room if I find something interesting on the internet, and kind of just tell you a little bit about it. But you can, if you're in our chat room, you can click on it and read the article a little bit later. We'll also put these articles onto the Space Pirate Facebook page too. And by the way, if you haven't checked lately, yes, I changed the picture on the Space Pirate Facebook page. So check that out. So this is NASA's Curiosity rover, which has been on Mars since 2012. And that's the one that's going through Gale Crater up Mount Sharp. And this article shows what its capabilities are for actually looking at color features on Mars. So it's not a I don't know if this is a black and white camera with filters, or is it a color camera? I didn't even check that one out. Yeah, two ways of basically doing color with a camera. One I'm sure that you're mostly used to from your everyday camera, that the pixels inside your camera, which are tiny little light-sensitive squares inside your camera. There are some that have basically filters in front of each pixel. One would be a red filter, yellow filter, blue filter. One of those filters will be over each pixel in your home camera, and take a picture. And since the little dots are small enough, you can kind of the picture comes out to be looking like a normal color picture. The other way is with a black and white chip that most astronomy cameras have, and then you put a filter in front of the entire camera, in front of all the chips at once. Take a picture with one color, say red, and then take another picture with a blue filter, another picture with a yellow filter, and then computerized combine them all back together and get it. Then it becomes a color filter. Yes, I've had it confirmed now. Yes, the Curiosity camera is a black and white camera, and they just put filters in front of it. And different types of filters. You can put a what's called a narrow range filter or a wide range filter. So basically a red filter will be centered on the red portion of the spectrum, but it might be a little bit more towards the infrared, a little bit more towards the yellow, somewhere in between. The yellow one, again, might be a narrow wavelength where it only looks at a very narrow portion of the yellow light, or it might actually bleed into the yellow, into the red end a little bit, or red towards the blue end a little bit, which gives it a little bit of a green tinge. And the same thing with the blue filters. So they could either be a very narrow band of each of the colors, or they could be a fairly wide band of each of those colors, and that just determines how the camera will actually see. So advantages and disadvantages to both having narrow band filters and wide band filters. For astronomy cameras, some of the advantages of having narrow band filters are as if you're taking images of things in space. So, for instance, if you're looking at a very red object in space, having a narrow band filter will get rid of the other colors and be able to enhance all the red features. And the same thing, there's different chemicals in space will actually emit different colors, and if you have a narrow filter, for instance, also a narrow filter will also get rid of distracting light, such as light pollution and street lights and things like that. So allow you to take pictures of objects in the nighttime sky without having things such as street lights fuzzing up your picture and bringing out the colors more accurately that way. Now, also don't be fooled by some false color images. A lot of people were fooled. I think was it the Voyager ones where they had Saturn pictures with green and yellow and blue and red stripes all over Saturn. People thought, oh, this is what Saturn looks like. It has all these different colors, bands all over it. It was like, nope. What they did was a black and white camera with filters, and then they took the colors, it picked it up, and enhanced different features by changing the color of it. So if you have, let's say, a white object and a gray object, and then an almost black object. Well, let's give them 3 different colors. Let's make the really bright stuff yellow, make the grayish stuff green, and the really dark stuff blue, or pick any colors. Yeah, basically it's just a way of enhancing the grayscales by assigning them a different color. So the object will look like it has different colors in it, but it's not. It's just the person that processes the image adds colors to different gray tones just to enhance different features. And that's what those multicolored pictures of Saturn were way back when, and they're not the actual colors. So look for under the captions, film credits, where it says false color, and that'll give you an idea. It says there's a false color picture of a thing on Mars here that kind of looks like a leaf in a rock. But yeah, they just change the colors to, again, increase the contrast, just to bring out the image a little bit better. I'll say something else about false colors too. What was that? Oh well, you get the idea. So not all colors are true colors. Sometimes they try to make the colors as realistic as possible to give you an idea if you were standing there looking at something, what it would really look like. And sometimes they add colors to they change the colors just to bring out different features and enhance them more. Now, this is especially true when you get away from the visible range of people's vision. So we generally see from way down into the red and way up into the blue violet range, but beyond that, for instance, there is ultraviolet that we can't see, and there's infrared that we can't see, but cameras can actually see those ranges. So let's say you have a camera that could pick up a wide range of infrared, longer wave infrared, shorter wave infrared, and everything in between. Well, if you take a picture with that, well, there's no way of colorizing it because it's invisible, but the camera does pick up the light. So you can determine the frequency of the picture. Say, okay, this has a filter in front of the camera. It's picking up long range red light, infrared light, or you can put a different filter in that has medium range infrared light, and then you could put another filter in that has higher frequency and lower frequency, I should say, of infrared light. So they can just pick some colors. Let's pick 3 different colors. Let's say for long range infrared, we'll make that blue. High range infrared, we'll make that red, and for medium range infrared, we'll make that yellow, and combine them together. So it kind of gives you a false color picture, but all the frequencies would be invisible to the eye. So basically just, if it was going to be a simulated color picture by converting invisible light into visible light and then showing what the object would look like. Again, it's strictly the option of the person processing the data to determine what the colors would look like. And the same thing could be done in, for instance, ultraviolet. Different frequencies of ultraviolet, from high frequency to low frequency, all in ultraviolet, invisible to the eye. Well, just basically pick colors for individual frequencies and combine them together to make a picture, a false color picture. And you kind of continue on that way. Same thing too. You might have actually seen radio pictures of things out in space. Well, radio waves, of course, are not visible to our eye. So one frequency, they will just pick a color. Another frequency, pick another color. Again, combining invisible light and assigning them a color and putting together a picture, whatever makes it seemingly pleasing. Same thing with X-rays. You can do the same thing with X-rays. Again, different frequencies of X-rays. You could just assign a different color and make a picture out of it. But really, it would be completely invisible to our own human eye. We have a very limited range of frequencies that we can actually see of the electromagnetic spectrum. Oh, see, we've gone a little bit past our halfway point, so we'll do a little bit of station identification. You are listening to Space Pirate Radio here on Astronomy.FM. It is now 9:30 in the evening on November the 1st, 2017 for those of us here in the eastern portion of North America. Universal time, that would put it at 1:35, November the 2nd, Thursday morning, Universal time. So if this happens to be your time right now, that yes, you're listening to me live. You also might be listening to me on a repeat. We'll repeat this program every 4 hours for the next 24 hours. And from what I remember, we should have our usual lineup of programs after Space Pirate Radio, which will include Astronomy Ireland. I always want to say hi to the guys in Astronomy Ireland following Space Pirate Radio. Also, Planetary Radio, Naked Astronomers, Naked Scientists, all coming up after Space Pirate Radio. So keep listening in. And of course, right now, I want to invite you to come on, join the crew. Come on over to the chat room and say hi if you just want to. If you've never been here, just pop in, say hi. Kind of nice to if you just say where you're listening in from, what general country would be fine. You want to get more detailed with the closest major city, that would be fine too. So far in our chat room, we've got Evil Spock, Twist Edge, Plaid Mac, Plaid Joan, Richie, Aqua for You, Optronics, Plaid Sister, and Norge. Yes, you don't have to actually use your real name in our chat room if you don't want to. That's just fine. So come on over if you've never been here. Got any questions for me, feel free to ask. Let me scroll back through our chat room and see if anybody's got any astronomy questions for me. And I will be more than happy to answer them on air for you. All right. Yeah, sorry. Yeah, somebody reminded me of station identification time 5 minutes ago. But yes, I was looking at Mars from the NASA homepage and that mission. Yeah. Oh, let's see. Last date. Oh, is it too late? Last day to send your name to Mars on NASA's InSight lander. Let me click on that article and see when that was. When the actual last date. I thought it was November the 1st. Let's see. New submissions will be accepted through November 1st, 2017. So you've got just a couple more hours to be able to send it there. The link is mars.nasa.gov/syn/insight. I'll click on that link and I'll pop it into our radio chat room, and then it will be on our Facebook page in a little bit, Space Pirate Facebook page. Or just go to the NASA website, and you can look it up there too, right on the NASA homepage. Article on that. You can click on that. So send your name to Mars. Maybe when I get off the air tonight, I'll go to that link and see if there's still time to send my name to Mars. Never did it before. Some people do it regularly for all the missions. Fun stuff. NASA's planning another rover for the planet Mars. It's going to be Mars 2020. Heavy on cameras. It says Mars rover will have 23 eyes. Is that separate cameras, or is that cameras with different sensors on it? Let's see what the article says here quick. I can catch it. We'll have more eyes than I wish they would print this as like real information instead of trying to be fun. Just say what it is. Will you guys, get to the point right ahead of time? You want to make that term eyes in the headlines? That's fine. But how about just real information right when you get into the article? Until 23 great sweeping panoramas reveal obstacles, study the atmosphere, and assist science instruments. Now, is that cameras, or is it? Let's see. There will be a camera inside the rover's body, which will study samples they've stored and left on the surface or collection. Well, we're going to have to delve into this one a little bit more by reading through the article and find out what they mean by eyes. Well, definitely must mean more cameras. Let's see. On the new rover, the engineering cameras have been upgraded to acquire high-resolution 20 megapixel color images. Okay, definitely better cameras. Let's see, routinely using 3D images. All right, so some 3D imaging capability. So that's always fun stuff. So we'll see. I'll have to read the article. I guess still got a few more years before it launches to figure out what they really mean. They've got some lists here. I've got a NavCam, MassCam Z, SuperCam, remote image, micro imager, another MassCam Z, another NavCam, two NavCams, two MassCam Zs, Sherlock Watson, interesting, Pixel micro context camera. There we go. Total of 23 cameras, 9 engineering cameras, 7 science cameras, and 7 entry, descent, and landing cameras. So that's what's going on the next rover towards Mars, rover 2020. I like Mars. Always a fun planet. Let's see what we've got here. Kepler mission. Kepler detects transiting comets outside of our solar system. And if I recall, let me put this article into our chat room here. This is also in cooperation with some amateur astronomers. This article is from SciTech Daily. And so not only, well, it's kind of the same thing, like detecting exoplanets. One of the main ways of doing it is by watching a star, measuring its brightness, and then if you actually see the light beginning to dim, that means something is generally either gone in front of it or it's actually a sunspot on the star. So it could, basically, astronomers can watch the dimming and find out if it's on there for a limited amount of time. The limited amount of time that the starlight has been dimmed will tell them that the dimming is transient. It's not there permanently. And if it reoccurs in a certain period of time, and it keeps reoccurring after a certain period of time, that tells them, yes, it is an orbiting object. Sunspots generally tend to get bigger and smaller. So if it's the same amount of dimming regularly occurring in front of the star, that tells them that, yes, it's actually a planet going in front of the star that happens to be lined up with the Earth. Now, I think this one, in order to determine that it was actually comets, I'm going to just guess that the dimming was a bit variable. The dimming was like 1% of 0.1% of the sun's light. So yes, pretty subtle dimming. And if it's variable, that would be maybe indicating that. And plus, looking at the spectra, and analyzing the sun's light would be able to pick up different chemicals in the sun's light changing. So combined together, they're thinking that they've actually picked out some comet tails going in front of the star. And amateur astronomers contribute to projects like this too. So yes, amateur astronomers can detect dimming of stars and report them. And then the pros can confirm it and study it even further. All right, let's see what we got here. About 15 more minutes. Oh, I want to go. I haven't done this in a while. Some alert notices from the American Association of Variable Star Observers. If you want to help with some real science on an astronomy, for astronomy projects, yes, the American Association of Variable Star Observers, professional astronomers ask amateur astronomers to help collaborate with their projects. So the latest one, now this one's kind of a last minute thing because I just found out it was actually posted about 3 or 4 days ago, but still kind of right on the edge. Project to observe a star a variable star in Aquila, which is usually quiet at magnitude 16th, but it can actually get bright up to 8.5 magnitude. So a good one for amateur astronomers because you don't actually have to see the star. In fact, it's better, according to them, if you don't see the star. They want you to observe where the star is located at, and then if you actually see a star there, report your observations. They're going to be using the Hubble Space Telescope to observe the star, and if the star is actually brightening, it could actually damage the equipment, the very sensitive equipment on the Hubble Space Telescope. So they want to observe the star when it's really dim, analyze its light, find out what's going on there, find out why it's varying, studying its chemistry. So they want to observe it when it's nice and quiet and it's not getting brighter. So they want as many observations as they can to happen before they point the Hubble telescope there. So if the star is actually going to be getting a brighter, well, they're not going to point the Hubble telescope there. They'll point it at something else. So you can actually contribute. So at 16th magnitude, which is pretty much too faint for most amateur telescopes to see, all you have to do is point your scope there, report that you don't see it, and if 10 people, 100 people, or 1,000 people also report that they don't see the star a day before the Hubble looks there, most likely the next day it's not going to get brighter and damage the equipment. So yes, not seeing a star is just important as actually be able to see. Now, if a bunch of people also report, yes, they can see it. I have a 6-inch telescope, and I can see this star. I don't know how bright it is, but I have this size telescope, and I can see the star. Well, obviously, a 6-inch telescope is not going to see a 16th magnitude star, so that means yes, it is getting brighter, and that means they would turn it away. So you can go to the American Association of Variable Star Observers. Look right on the homepage where it says Alert Notices. This one is Alert Notice 603. This is actually a type of star that is kind of a variable nova, a recurrent nova. Last time it got bright was in 1941 and in the year 2000. So it doesn't happen regularly, and it obviously doesn't seem like a regularly dimming and brightening star. Mostly stays quiet, and then all of a sudden it gets brighter. Usually because it has a companion star that's dumping material onto its surface. When it gets enough material on the surface, that stuff ignites and it gets bright again. So they want to study this one, and they don't want to ruin the Hubble Space Telescope while doing it. And another notice too. Let's see. They want more notices. 603 notice 604 also. Gives the deadline for reporting this, but they also want observations through the end of November. So that'll, even though they won't be able to use the Hubble Space Telescope later on this, but at least they'll give them an idea that the star has been steady since before their observations, and the star has been steady up till the end of November also. All right, so check out those notices by going to the American Association of Variable Star Observers. Even if you don't want to report your observations, it's a fun one to try. Aquarius is out in the evening. Northern and Southern Hemisphere observers can easily see it. So if you want a little bit of a project while you're out observing, just see if you can actually find the star. And even if you don't want to report your information, just give it a shot. See how well you can actually find the position of the star, so that if you did find something really important, you would be able to report your observations. You might discover the next Milky Way supernova. And if you did, would you be able to determine exactly where it's located in the sky within a few arc seconds, instead of just saying, well, it's in the constellation of so-and-so? Not good enough. And it's about sort of bright. The sort of bright makes no sense to anybody. So you have to be able to determine how bright something is by comparing it to another star. And as close as you can get to brightness, they prefer at least 1/10 of a magnitude, and be able to tell them where the star is located within a fraction of a degree. Can you do that? Something good to practice when you're out observing. Now, if you're like a lot of people, you'll go look at the moon, a couple of planets, and then some deep sky objects, and maybe that's it. Well, after a while, you get used to seeing those objects, and like most of the deep sky objects in the northern hemisphere, visible in an 8-inch telescope, I've seen already. Kind of saturated the whole northern hemisphere with an 8-inch telescope. So sometimes it gets a little bit boring to go out and do some observing. So yeah, have some projects that make it a little bit more interesting with a little bit of purpose. Will give you a little something extra to do when you're outside doing some observing. Has anybody done any asteroid observing? Yeah, there are asteroids out there. How many of you actually have seen asteroids? I've seen a few, not a lot. I think I probably have seen more comets than asteroids, actually. Yeah, this is something I haven't really done a lot of observations of asteroids. It's like, I kind of keep forgetting when I go out there, and I think, I could look for some asteroids, and thought, I forgot to bring the data of where the asteroids are actually located at. I should kind of do that next time. And how about the fainter planets like Uranus and Neptune? Pretty easy to see both of them if you know right where to look. For instance, the planet Uranus is in the constellation of Pisces, and Neptune is just northeast of star Fomalhaut, which is in Pisces Australis. Oh, that's interesting. Is that true? Both of them are in Pisces? I mean, a sort of Pisces? I think so, yeah. Uranus in Pisces and Fomalhaut, Neptune is near, Neptune is near Fomalhaut, which is Pisces Australis. Get out there and have some fun. Unfortunately, this weekend is not going to be the weekend. A little bit too much moon this weekend. Let's see. Aquafuse says, like to see the asteroid Psyche. Is it visible in amateur telescopes? I don't know. I have to look that one up and find out if it's bright enough to actually see. He says, stupid moon. If you're reading the chat room right now, yeah, the moon does get in the way of a lot of fun observations. But I should say the full moon is worse for that. Now, the before and after the full moon, that's actually a lot more interesting time to look at the moon. Everything from very thin crescent through almost full moon. The line between daylight and nighttime is called the terminator. And along the terminator, that's when the sunlight is actually hitting the craters at a 90-degree angle, almost completely sideways. And that's when you see the most contrast on the moon. So you can see shadows. And if you watch carefully, you can actually see the shadows on the moon move. Especially if you do observations from like early in the evening to later in the evening, which is, I know, kind of difficult because the moon's not always out that much. So you can only do that when it's just before and just after full moon. Can you actually see some shadows move across the surface like that? But if you take regular notes of some specific features and even do some drawings or photographs, you'll notice that at different times in the moon phase, you will see shadows of different lengths, even on the same feature. So try that. Try really noticing detailed features of shadows on the moon. Either, for instance, there are mountain peaks in the middle of craters that you could see along the terminator, and you watch them from the beginning or as soon as you get up, set up, look at that, and then when before the moon's going to set or later in the evening, look at it again and see if those mountain peaks have actually changed. They've either gotten brighter or smaller, either way. And try looking for some real detail. One moon project I've done in the past, and I really need to do again, is how small of a feature can you actually see on the moon. And there's a bit of a challenge. So you have to have some really clear skies, steady air, good telescope, good collimation, some good eyepieces, everything combined together so you can get as high a magnification as you can through your telescope, looking at craters on the moon, and not the big craters, the small craters. And be able to identify those craters on a moon map, whether it's computerized or paper, and then figure out the diameter of those craters. And the smallest craters on the moon that you'll be able to see should appear as a single dark dot. And depending on how good your scope is and equipment is and the night and everything will determine the size of the actual smallest crater you can actually see. I was surprised. I was using about 400 power in my 8-inch telescope, was able to identify a tiny little dot on the moon, went to my moon chart later, compared it, looked it up, measured the chart, figured out the diameter of that crater, looking just like a little black dot, was 3 miles in diameter. That's that's a big crater, 3 miles. But it looked like, said, just a tiny little dot through my telescope. Give it a shot and see what you can see, and you might actually notice that you'll start seeing other features besides craters and mountains. You'll see river like rills, like squiggly lines on the moon, probably collapsed lava tubes, different tones. You can see where craters have hit and splattered out dirt and rays, different contrast. All kinds of fun stuff to look at the moon if you give it a real serious effort. If you want to, here's an article. I'm just going to pop it in here and mention it real quickly. If you want to get into a little bit more hardcore science, like I do once in a while, here's a little bit more of a hardcore science article about dark matter. And a team at Brown University is trying to develop a method of detecting dark matter using a pool. They call it a tub of superfluid helium. Yeah, you'll have to look that one up too. And having maybe particles of a certain size interacting with the helium, and that would tell them that the dark matter particles might be of a specific size, and that might be what's causing them. So most large-scale dark matter searches so far are looking for particles with a mass somewhere between 10 and 10,000 times the mass of a proton. This method, if they can actually get it to work, will detect particles below 10 proton masses. If you want to get into something a little bit technical, go ahead and read that article that I just put into our chat room, which will end up in our Space Pirate Facebook page. Well, everybody, time for me to head on out here. I want to thank everybody that's been listening in tonight. Really appreciate it. Don't forget, we got more programming coming up, including Astronomy Ireland, Planetary Radio, Naked Astronomy, Naked Scientists, coming up after Space Pirate Radio. Thanks, everybody that's been in the chat room tonight. Really appreciate you being here, and I'll see you all again next Wednesday. Good night, everybody.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
AFM.